right. And I guess I should say something about the quizzes. All right. That's kind of the format that a quiz is going to go. Okay. In my opinion, it was a very fair quiz. On the homework page, I listed off all the topics that you need to know, and I feel like if you studied those topics, you would have been prepared for this quiz. Okay. I do also have office hours, and if you have questions about any of those topics, you can come see me during office hours.
Is it 6 to 7?
Office hours are from 5:30 to 6:30. Okay, so all of that information is also on the course webpage. Okay, if you took the quiz and you just have a terrible feeling that you did awful on the quiz, okay, then either you need to spend more time in preparation, or you need to come see me during office hours, or something's got to improve. Okay. I'm gonna grade the quizzes, and I'll return them to you next week. And there was 30 points possible on the quiz. I think one of them, the very last question, I have the points counted wrong. It's just worth 1 instead of 3 points. And anyway, but I grade them out of 25. Okay, so. Even if you lose 5 points, you're still going to get 100% in terms of the grade book, okay? But that's very, very, very generous. I don't want it to give you a false impression that you're doing a lot better than you actually are, okay? It's just to boost your grades, okay? Yes?
Is it like that on the test as well?
On the test, I also include some bonus points in there, okay? But it's not as drastic as for the quiz, okay? So the quiz, I mean, that's like, if you get full 100 everything right, you'll get 120%, which is kind of ridiculous. But
and it'll add them on to other things that you get.
Yeah. I mean, everything adds up. Okay, so I mean, you get 120% on your quizzes, but you do poorly on your midterm. It evens out. Okay.
And it's 4 questions each quiz, right? 4?
I mean, it depends. It depends, all right? And but you know, some of you will get like 15 points on the quiz or something, okay, or something less than that, okay, and that's a bad grade, all right. I don't want to give you guys any hope that if you got 15 points on the quiz that this is that's okay, all right. That's bad, all right. So
that's 50%.
15, yeah, 15 would be 50% if I counted all 30 points. It'd be 60% with the adjustment, but. I mean, nobody should be proud of that. So, so if that's you, you know what happens next week. You know, when you get your quizzes back, then we should talk, okay, and see if this is a good fit or not for you. So. Okay. So anyway, today we are moving on to chapter 4. Okay. And in chapter 4, we are going to explore a relationship, okay? Not a romantic relationship, but we're going to explore relationships between variables, okay? Okay? And actually, a lot of statistics is exploring relationships between variables, okay? In chapter 4, we're looking at a specific type of relationship, and this is a relationship between 2 numeric or 2 quantitative variables, okay? In other parts of the course, we'll explore relationships between a numeric variable and a categorical variable. So, for example, you know, are the heights of people related to their gender? Okay, that's a categorical variable, gender, and numeric variable, someone's height. Is there a relationship between their gender and their height? Yes. Okay. In general, women are shorter than men, or in general, men are taller than women. Okay. Now, of course, some things are different, but that's the general relationship. Yeah, Daniel.
If you put height as instead of numbers, like inches or something, you put tall and short,
Okay.
would that be categorical?
Yeah, I mean, if you change height into a categorical variable, right? Like you go to an amusement park, and they say you must be this tall to ride, okay? And that basically categorizes everybody based on their height. People who can go on the ride, people who are too short for the ride, okay? And that would turn it into a category. But that's more of an exception to the rule, okay? We're going to just deal with numeric variables, okay? But here, we're not dealing with categorical and numerical. We're just dealing with two numeric variables, okay? So here's some examples. Is there a relationship between someone's height and their weight? Okay. The stuff we learned today can answer this question, all right? Because height is one variable, and that's numeric. Weight is another variable, and it's also numeric. Okay, so we can explore this relationship. Okay. Another example, is there a relationship between someone's age and that person's height?
Yes.
Okay. Also, we have two numeric variables, and so we can explore this kind of relationship. Okay. Things like maybe is there a relationship between the cost of a house numeric variable, okay, and the number of square feet, okay? In the house, okay? So these are all different examples of potential relationships that we could explore, okay? So these are all kind of reasonable ones, but we can even have silly ones, all right? Is there a relationship between someone's IQ? All right, so IQ, you get a numeric score on a scale, all right, where 100 is average, and that person's shoe size. Okay, so all of these these relationships we can we can take a look at. Okay? Now, the first thing to do when exploring these kinds of relationships. Okay, well let's think of what would the data look like if we wanted to look at this, explore one of these things. Okay, what would our data table look like? Alright, so let's say we wanted to explore the very, let's look at the very first relationship. Okay, is there a relationship between someone's height and their weight, that person's weight? What should our data table look like? How am I going to collect data here?
We should have like cases and
Okay,
then
yeah. So what is
numbers
each of my case? So what's a case in my data table?
average male, female, or height, no.
Okay, so what is my who? All right, cases are who. Yeah, each person is a case. All right, so the person 1 could be Adam, and person 2 could be Bob, and person 3 could be Carol, and things like that. Okay, and we can have a list of people. And each person forms a case. And what is the information that I'm collecting for each person?
Height and weight.
The person's height and their person's weight. So what is Adam's height? Well, Adam is 70 inches tall, and he weighs 180 pounds, okay? And Bob is 68 inches tall and weighs 165 pounds. And Carol is 63 inches tall and weighs 120. And Denise is 66 inches tall and weighs 140. Okay, so I'm just making up some numbers here. Now we want to know, is there a relationship, okay? And of course, anytime we're going to do something like this, I would hope we have more than 4 data points, but this is enough to get us started here, okay? So just imagine that there's even more data, meaning I've collected information on more people, and each person is a case here. Yes, we had a question, Helen? No. Okay. So we are going to graph this using a scatter plot. And creating a scatter plot is just like graphing data points when you learned algebra. Okay, so you create x and y coordinates. So, for example, this would form the coordinate pair 70, 180. And this would form the coordinate pair 68, 165. And you are going to take each of these data points. So here I only have 4, but I'm going to take each of those and I'm going to graph them up on here. Okay, so. Here I formed a scale here, and so I'm just going to graph every single data point, okay? So 70 inches is right here, so I go up 70, and I'm going to go over to 180, up to 70, and this is my first dot here, 70, 180, okay? Now, the dots are normally not labeled, but I'm just labeling this first one so you guys can see that, okay? All right, so this is okay with everybody, right? This is just plain old graphing dots. So I'm going to graph all 4 of these dots. I got 68 and 165. So somewhere around there. And here's 120 and 63. And here is 140 and 66. Okay. All right, so there's just 4 dots here, and I want to ask, is there a relationship, well, based on these 4 dots, is there a relationship between someone's height and that person's weight?
Is it positive correlation?
Okay, yeah, so we'll talk about terms like positive correlation in a moment here. But
So,
there is, yes, there is a trend here, okay? appears to be a trend. Okay, and it seems that as the height of someone increases, their weight also tends to increase. Okay. Or I shouldn't say as not of someone. Okay. So in our data, okay, all right, points with, I guess, above average height also tend to have above average weight. Okay, that's actually a better description of the trend. Okay. So when we look at all of the data, it seems like average is I could add up these numbers and divide by 4, and the average would be somewhere around here. I'm not entirely sure. And then if I did the same thing with weight, it would be somewhere around here. Okay, this would be kind of the average weight and the average height. Okay, so if I label height as my x variable and weight as my y variable, I can figure out y bar and I can figure out x bar, right? So x bar, I would do here. We'll just do this for real. 70 plus 68 plus 63 plus 66. 267 divided by 4, 66.75. Okay, so my x bar is 66.75, and my y bar, 180 plus 165 plus 120 plus 140 divided by 4, 151.25. Okay. And what we see is that, so this vertical line here represents my average height. Is that correct? Of the 4 data points. And we see that the people who are above this average line also tend to be above the average line here. Okay? And people who are below the average line also tend to be below the average weight line. Okay? Does that make sense?
How did you do the mean again?
I just added the 4 numbers up and divided by 4.
Oh, okay.
Yeah.
All right. But why did you do the cross?
So I did it. I have 2 variables, right? I got x. I figured out the mean for x. What's the mean of these 4 numbers? 66.75. And what's the mean of these 4 numbers for weight? 151.25. Okay, I'm just graphing distance. Yeah.
How'd you get that x in the middle again? You just kind of put an x in the middle. What is that?
So okay. So this, are we okay with the mean being 66.75 and the mean being 151.25? Okay. I'm drawing a vertical line at 66.75. This vertical line represents 66.75. And this horizontal line is what? 151.25. Okay. This represents the middle weight, okay, or the mean weight, and this represents the mean height. Okay. So this is this point right here is the average height and the average weight. Okay, and what we see is that people who tend to be above average in height tend to be above average in weight. People who tend to be below average in height also tend to be below average in weight. Now, of course, there's going to be exceptions to that. We're going to have some people who are tall but weigh less than average, people who are short but weigh more than average, okay? that's fine. It's just we've got, but in overall, well, especially with just 4 points, this is the trend that we observe. Okay. Yeah.
If we had more points and there were some that were inconsistent with our findings, could we still give that statement in the majority?
Yeah. So I mean, so here we only have 4 points, but this is just to give you the idea of where a scatter plot is coming from. Okay. Let's talk about what happens when we've got more data points. All right, so let's say we gathered a whole bunch of data on different people. All right, so and let's say this is what we see. Okay, this is still height. Alright, so this is more data on a whole bunch more people. We still see the overall trend, okay? We still see kind of this this type of trend here, alright? So we would still say the same thing. There appears to be a trend, and in our data, points with above average height also tend to be above average in weight, okay? Same trend, okay? Now, not everyone, okay? So, for example, here's someone who is above average in height, but seems to be below average in weight. Here's someone who seems to be way below average in height, but maybe a little bit above average in weight, okay? And so we have points that kind of don't fit in with everyone else, but overall, the general trend of everyone, this holds true. Okay. Here, when we see something like this, we say there is a positive relationship. Okay, and a positive relationship indicates that as one variable increases, the other variable also tends to increase, or the two variables move in the same direction. Okay. So as one increases, the other also tends to increase. As one variable increases. And the inverse is true also, right? If one variable decreases, then what happens to the other variable? It also decreases, tends to decrease. So that's a positive relationship. And that's things like height and weight, right? Okay, can I erase this?
Oh, not yet.
Not yet. We'll erase this one then. Alright, on the other hand, maybe we've collected data that looks something like this. what could be represented by a relationship like this? Okay, so I mean, so if this is positive, we could say this is going to be a negative relationship. So, all right, so what might have a negative relationship? What two variables might have a negative relationship?
If they go in different directions?
Yeah, okay, so can anyone think of an example here? Sure.
The price of houses that rise and the amount of people that can afford them.
The price of a house and the what?
And
How many
the
people
more
can
expensive
afford
the house
it?
gets, the less people can afford it.
Okay, yeah, so the number of people who would qualify for this loan or that qualify to buy this house and the cost of the house. Yeah, that's a great example, okay? So so this we will write as a negative relationship. Okay, and so one example, cost of a house, okay, versus number of people who qualify to buy it. Okay, so if a house costs $50,000, so if you go to like Wyoming or something like that, you can get a decent house for $50,000. A lot of people would qualify to purchase that house, okay? You try to buy a house around here, it might cost you like $1.2 million. Who can qualify to buy that? Not very many people, okay? So you have a negative relationship. The higher the cost of the house, the fewer people can afford it. Okay, this is a great example. Great example. All right. Can anyone think of anything else? Okay. So what I had in mind was okay. So let's take some model of a car. So let's say a Honda Civic here. All right. And we can think of how many miles were driven on the car, and how much we can sell the car for. Okay. So the value of a car versus number of miles driven on it. Okay. So number of miles driven and value of car. So in general, if you drive a lot of miles on a car, the value of the car goes down, okay? But yeah, you know what? There might be some cars where a lot of miles have been driven on it, but it still is worth more than another car that had fewer miles driven on it because maybe it had it's in better condition, or there's other factors that go into how much a car is worth other than how many miles were driven on it. But number of miles driven is a pretty good indicator, right? If a car has 200,000 miles on it, it's certainly probably going to be worth less than a car that with 50,000 miles. Yeah.
So you're saying when it goes to the right, it's positive, when it goes to the left, it's negative? Is that what you're saying?
No.
Or no?
So there's
Because over there it goes to the right.
So there's no, I wouldn't say going to the right and going to the left, okay? So over here we got some kind of trend like this, all right? So in a positive relationship, the two variables move in the same direction, okay? That would be a much better way to think of it rather than going to the right or going to the left, okay? Over here, in a negative relationship, the two variables move in different directions. So in general, as one variable tends to increase, or as one variable increases, the other variable tends to decrease. Okay? Or as one tends to decrease, the other variable tends to increase. So that's a negative relationship. Okay? So other things that also have a negative relationship, but these ones would be like almost very direct, would be the altitude of where you're living, and the air pressure. of where you're living, right? So if you live in like Mexico City or Denver, where you're on top of a mountain, the air pressure there is lower, okay? And if you go to like, you know, Death Valley or something, where you're at sea level or below sea level, you know, the air pressure is a little bit higher, okay? We're humans, so we're not like super sensitive to changes in air pressure, but certainly instruments can tell us that, right? We have barometer that tell us things like that. All right, so that explains kind of basically the two directions of a relationship. You've got positive and a negative. Positive trend and negative trend, or positive relationship and negative relationship. Okay.
I have a question.
Yeah.
So you can tell that just by looking at the graph, or
Yeah. So when you create a graph, you know, you're either going to have a positive or a negative or things like that. Okay. But sometimes you have graphs where it doesn't quite. Okay, so maybe what could this be an example of?
Could be height.
No, height doesn't call something like that. Okay.
Well,
Well, I
for men
can't-
and women,
Huh?
there would be two different.
Okay, so what you're saying about men and women would not work because men and women is a categorical variable, and we can only here describe relationships between two numeric variables. Okay?
So it wouldn't be like the heights of men and the heights of women?
So you need two numeric variables, right? So right now I'm only hearing one numeric variable. So when you're saying heights of men and heights of women, I'm still only hearing one numeric variable, meaning
Okay.
there's only height here. Okay, I'm only hearing that. Okay.
Rise
So
of the houses?
Yeah.
the temperature of an oven compared to how quick something cooks, the time, the seconds it takes, or the minutes.
Okay, so I would think that would be just strictly negative. Well, okay. Let me. We'll think of something. Okay. Or you know, maybe you have a relationship that looks something like this. Okay. This could be a person's age and their height. Okay. Where when they are, you know, between 0 and 15 or something, their height is increasing. Okay, so as a child, the height increases, but then once they reach adulthood, the height no longer increases. Okay, maybe even in old age, it goes down a little bit. Okay, who knows? All right, but height and age might look something like this. Okay, so these we cannot describe with just a straight word like positive or negative relationship. Okay. So that's what we've got going on here, all right. And so what we're and one thing is that these types of relationships cannot be described with a straight line, okay.
So would you call these cyclical?
Not cyclical, okay. Cyclical would imply something to do with time, and these not necessarily to do with that, okay. So these relationships cannot be described with a single straight line. So for example, this one up here, this straight line kind of just captures the essence of the relationship, all right? I mean, it doesn't show us all the dots and the details of what's going on in it. But the straight line kind of just captures the essence of it, okay? Over here, you'd be hard-pressed to find a single straight line that captures what's going on in either this picture or this picture, okay? And so we call these non-linear relationships.
Both, right?
Yeah, these are both nonlinear, okay? Nonlinear because here you can see the word line in linear, okay? Meaning a single straight line does not capture it, okay? So that nonlinear is basically this definition right here. And in this class, we're only going to learn about how to describe and do analysis with linear relationships. Okay, so a linear relationship is a relationship where a straight line can kind of capture or describe the relationship.
With a single straight line.
Used to describe or summarize the relationship.
Yeah.
I don't need quotes around that. Okay. All right, and so that would be an example of a linear relationship. Anything where you've got, you know, even so there's a linear relationship also. So anytime a single straight line can kind of just capture the essence of the relationship, you've got a linear relationship going on. Okay. All right. So far, when we're describing a relationship, we've talked about two things. All right. Well, what is one of those things we can talk about? Yeah, whether it's positive or negative. Okay. So when describing relationships, relationships between numeric variables okay, we can talk about the direction being positive or negative. And we can also talk about what? Alright, and the other one is shape, whether it's linear or nonlinear. Alright, and there's one more thing that we can talk about. And this is the strength. So this, we can use any words that you would use to describe the strength of a person. So weak or strong, maybe not buff, but I don't know, weak or strong, you know, whatever you want to say, or something in between. Okay. And we can also describe these with numbers too.
Is this the weak or the strong, is it depending on how close the dots
Yes,
are together?
I will talk about that right now. Alright, so if you think of a scatter plot and what we might see, okay. Alright, we might see something like this, okay? And this would be, an example of this is, I take a car, a toy car, and I maybe put in some batteries and I turn it on and I put it on the ground, and then here I'm counting in seconds how many seconds I've left it to drive, and this and on the other axis I'm measuring how far it has driven. Okay, so this is, I could say, number of seconds since I released the car, released the toy, versus how far it has driven. Okay, so maybe you know, at 0 seconds it's gone 0 feet, and then after 2 seconds maybe it's gone 1 foot, and after 4 seconds it's gone 2 feet, and after 6 seconds, how far would it have gone? Probably like 3 feet, okay? And so I can measure this, and it would form a perfectly straight line, okay? If I measured how far the car has gone, and I'm counting, you know, after this many seconds it's gone here and here and here, okay? All right, so this would form a perfectly straight line, okay? So this is distance, this is time. And so this we would say has either a perfectly strong relationship or just an extremely strong relationship, okay? Just extremely strong. Huh? And so if a relationship is very, very strong, it means when you draw a kind of a summary line, the dots are very, very close to the line. Okay, they're either perfectly on the line or the dots are very, very close to the line. So in a very strong relationship, I should say a strong linear relationship. When we create a line, summary line, the data points are very close to the line or lie perfectly on it, okay? Alright, so that's, I'm sorry? Is there a question? No? Okay. Alright, so that's a perfectly strong relationship, okay? On the other hand, if there's lots of scatter, then we would say we have a weak relationship.
And the last one is a linear relationship. Right?
Yeah, this is still linear because we've got a straight line going on, okay? So maybe we've got something and we've got, I don't know, trend like this, okay? So here we've got lots of scatter. Okay, we still have a straight line relationship. A straight line can still describe this relationship. So it's still a linear relationship, okay? But we have a weak relationship. Lots of scatter around the line. Okay, so this could be something like the temperature outside and the number of people wearing shorts. Okay, so in general, as the temperature goes up, the number of people wearing shorts also goes up, okay? But it's very unpredictable, right? If the temperature goes up, you might still have a bunch of people who aren't wearing shorts, okay? And even when the temperature goes down, you might still have a bunch of people who do wear shorts, all right? Usually, whether someone wears shorts or not, that's more related to what month of the year it is, okay? So, I mean, especially in, some, like California, every now and then in February, we'll get a really hot day, okay? But most people will still probably wear jeans or pants, long pants that day, especially because it's in February and all of your shorts are still in the closet or whatever, okay? And then, and on the other hand, it might turn May and you might get a really cold day or something, but then people might still wear shorts or something, okay? So you've got a weak relationship. So this is, that's a silly example, but this would be outside temperature and number of people wearing shorts. So you got lots of scatter around the world. And then sometimes if there's so much scatter that you can't even really pick out any kind of straight line. All right. At this point, which straight line fits, okay? This we could say, there's so much scatter that we could just say that there's no relationship. And this could be, someone's shoe size and their IQ. Okay, so that would be an example of no relationship. In general, people with big or small feet don't generally tend to have bigger or higher or lower IQs than other people. Okay, so here we've got no relationship. Okay, and you've got a few examples in the book to explore, and then you will see different examples of strong or weak or things in between. Yes.
I don't know where to put what to put on the x-axis or the y-axis.
Oh, it doesn't really matter. Okay, I'm just making up examples here. All right. Okay. All right. So when we were talking about one numeric variable, we would talk about its distribution. And what are some of the things that we could, so this is kind of a pop quiz recap. What were ways we could describe a numeric distribution or a numeric variable? What are some of the things we would talk about? Okay, the shape, and what would we say? Symmetric or skewed, or the other part of shape that went along with it was what? Unimodal, bimodal, things like that. Okay, so shape was one of them. Very good. What else could we say? Okay, so yeah, outliers and everything, but yeah, spread and center. Okay, we had center and spread. Okay, now how did we describe center? The mean and the median. Okay, so we had numbers to tell us where the center was. Okay, we had the mean and the median. Those were numbers that told us about the center. Okay, what would we use to describe the spread?
IQR.
Yeah, IQR, range, standard deviation. Okay, those were also all numbers that told us about the spread, where we saw larger numbers for standard deviation meant more spread, smaller standard deviation meant less spread, things like that. Okay, same thing with the IQR. All right, over here, to describe a relationship between two numeric variables, we can talk about the shape, whether it's linear or nonlinear. Okay, and we can talk about the direction, whether it's positive or negative, and we can talk about the strength, whether it's strong or weak or something in between, okay, or no relationship, okay? And just like we have the mean and the median, which are numbers that tell us about the center, or the standard deviation, which is a number that tells us about the spread, we have a number that tells us about the strength and a number that tells us about the direction, okay? But it's actually just one number. One number tells us both the strength and the direction. All right, and some of you guys know what this number is, or at least have heard of it.
Is that one?
It's not one. Okay, so we have a number that we can use to tell us about a relationship's direction and strength. Okay? That number is called the correlation. Okay. Okay. Actually, its full name is the correlation coefficient. Okay, but coefficient. All right, but we just usually just say correlation. Okay, or just for short we use. Okay, and just like the mean. We had a symbol. What's the symbol for the mean? X bar. Okay. For the correlation, we have a symbol,
R.
and it's R. Okay. The symbol for correlation. Okay. So a lot of times in just daily language, we throw out the word correlation to describe any kind of relationship. We say, oh, there's a correlation between this and this. All right. In statistics, correlation takes on this very specific meaning of a number that tells us about the direction and the strength. Okay. And this only applies to what kind of variables? Two numeric variables. So correlation only makes sense when you are describing a relationship between two numeric variables. And the other thing about correlation is that you're going to get this number, but it only makes sense, the number only makes sense when it's a linear relationship, okay? You can calculate correlation even if you have a nonlinear relationship, except there won't be as much meaning to that number, okay? Just like, you know, you can find the mean or the median for any set of numbers, but you know, depending on the context that you're using, it might make more sense to use mean or the median, okay? Or it might make more sense to use the IQR or the standard deviation. Here you've got the correlation, And here the correlation really only makes sense when it's a linear relationship, okay? Because it's just a number, you can always throw numbers into a formula and it's going to spit a number out. But the number it spits out only makes sense when it's a linear relationship. Okay? Correlation can be calculated for any relationship between numeric variables, okay? But only makes sense for linear relationships. So, let me just go for like 5 more minutes and then we'll take a break. So the correlation will tell you the direction, okay? And the correlation, so R can be any value between -1 and 1, positive and 1, inclusive, okay? So it can never be larger than 1, it can never be smaller than -1, okay? And if R is positive, it means you have a positive relationship. And if R is negative, the relationship is negative, okay? So that's simple, right?
Yeah.
Alright, if R is close to 0, or if R is 0, then there is no relationship. Okay? And if R is close to 0, the relationship is weak. So that's like 0.1 or -0.1, -0.2. Those are all kind of weak relationships. On the other hand, if R is far from 0, alright, so what's the farthest R can get from 0? 1 or -1, okay? So meaning close to 1 or -1, okay? Then the relationship is strong. So if you've got anything in between, then it's kind of a judgment call. Okay? Why don't we take a little break right there? We'll come back in about 10 minutes and